For number 1 on the review sheet, you're hired to call people to sell timeshares for your holiday job. I want to know how many 7-digit phone numbers can be formed if the first digit is not 0 and no repetition is allowed. Because I want to know how many possibilities or how many possible numbers I'm going to have to call. So I'm talking about a 7-digit telephone number, which means that I have technically 7 categories that I'm looking at. The first digit, the second digit, the third one, fourth one, fifth one, sixth one, and 7th one in this number. So that's the phone number. For a phone number in each one of these spaces, I want to look at what are my options for single digits that can be in those positions in that 7-digit number. So I know that I have 0 through 9, which if you count that out, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you have a total of 10 digits to choose from. So you have 10 digits to choose from that are single digits that can go in those spots, or that are options for that 7-digit phone number, each digit in it. Then first thing I want to do when filling in the options for each one of these categories is I want to look at the most specific restriction that I have. So the most specific restriction I have is that the first digit is not 0, which means that I'm going to take care of that first. So if it's not 0 for the first digit, that means I have only 1 through 9 as options. So only 1 through 9 is options for that, and that is 9 numbers. After I've taken care of that restriction, I'm going to take care of my other digits in this number. I want to keep in mind that no repetition is allowed. That's my second restriction, which I have to keep in mind when I'm filling in the options for the other digits in the phone number. Looking at the second digit for the phone number, I know that I've already picked one number. When I put these options here, that means I've already picked a digit to go in the first position, which means I only have 10 minus 1, so 9 options left for the second digit. After I choose the first 2 digits, I have 8 left that's 10 minus 2, so 8 left for the third digit, and then 7 left for the fourth, 6 left for the fifth, 5, and 4. These are the options for each digit in that 7-digit telephone number, but I'm talking about the 7-digit telephone numbers as a whole, or the 7-digit telephone number as a whole. I want to know how many options there are for that 7-digit number together. So what I want to do is I want to multiply all of these options for each category, if I treat each digit as a category, to find the total number of ways for that entire 7-digit telephone number. And if I multiply 9 times 9 times 8 times 7 times 6 times 5 times 4 in my calculator, I'm going to get 544,320 phone numbers. So that's how many options there are with those restrictions. For number 2, you're going to a holiday party with your friends. Your mom forgot to do your laundry, so you only have 7 tops, 4 belts, 3 pants, and 2 boots that are clean and festive. I want to know how many different outfits can be made. So I have 1, 2, 3, and 4. 4 different categories here. If I want to find for the outfits of putting those 4 categories together, I'm going to take 7 tops, 4 belts, 3 pants, 2 boots, and I'm going to multiply these options together to look at how many possible outfits when I collect these things there are, and that is 7 times 5 times 3 times 2 is 168 outfits. For number 3, I have how many 4-letter words can be formed using the letters snowflake if the letters are not repeated. So I'm going to start with not repeated. So I know that I can't repeat any of these letters. First, I'm going to count how many letters I have total. So how many options? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a total of 9 letters. 9 letters to choose from, or 9 letters as options. These, for A, they're not allowed to be repeated. So I'm going to start with, I have 4 spots available. So the first letter, second letter, third letter, and fourth letter in my word. I'm going to start with the first letter. I know that my first letter, I have 9 options for it. For the second letter, I have, because repetition is not allowed, after I choose the first one, I only have 8 left for the second one. After I choose the first 2, I only have 7 left for the third, and then I only have 6 left for the fourth. What I'm going to do to find these, I've separated this into categories. Each letter in the word is one category. I'm going to multiply these options together to get for the 4-letter words how many there are with no repetition allowed, and that's going to be 3,024 words. For B, if the letters are allowed to be repeated, I want to see how does that change it. I have still 4 spaces in that word, or 4 letters in that word. For the first letter, I have 9 options. For the second letter, it doesn't matter what I chose for the first letter, I could choose it again, so I have 9 options. For the third, I have 9 options, and for the fourth, I have 9 options. That's for each letter, each category. I want to know the 4-letter word together, how many ways. So I'm going to multiply these options for each category together, each letter together, and I'm going to get 9 times 9 times 9 times 9, or 9 to the 4th power, which is 6,561 words. For C, I want to know if they're repeated, but if they're repeated and must begin with a W. So again, I have 4 letters in my word. It must start with a W, so this must be W. If the first letter must be W, I only have one option, W for that one. If I am allowed to repeat the letters, that means that I can repeat W if I want. I have a total of 9 letters to choose from, so I have 9 letters to choose from for the second letter. Same with the third letter, 9 to choose from, 9 to choose from for the fourth letter. I want to know how many 4-letter words on a whole, so I'm going to take each one of these categories for each letter, the options for each letter. I'm going to multiply them together to get 4-letter words available, or 4-letter words possible, and that's going to be 1 times 9 times 9 times 9, which is 729 words. For D, I have the letters are not repeated and must end with an A or S. So I have a 4-letter word, and the last letter must be A or S. So that's 2 options. I'm starting with my restriction, the most specific restriction that I have, and then I'm moving from there. So I have 2 options for that. After I choose the last letter, I'm going to choose the other one. So I'm going to start with the first one here. After I choose A or S for the last, I'm only going to have 8 letters left to choose from. And then after I choose those 2, I'm only going to have 7 left for the second letter and 6 left for the third. And then I'm going to multiply all of these together, and I'm going to get 672 words possible. For number 4, I have a die is rolled, and I want to find each probability. So first thing I want to do is find the probability of 3. I know there are 6 total, so I always want to think about what's my total outcomes that I have, or possible outcomes. I have 6 on a die, so if to roll a 3, there's only 1 3 on a die, and that's so favorable over total is 1 out of 6, which if I calculate to percent and round to the nearest 10th place, that is 16.7%. For the probability of even or a divisor of 6, and this is if I'm just picking one, or I'm just rolling the die one time. So it's just rolled one time. So the probability of an even number is 2, or my options are 2, 4, and 6. So there's 3 out of 6. That's favorable. The favorable options is 3. And then I know if to be a divisor of 6, 1 is a divisor of 6, 2 is, 3 is, 4 is not, 5 is not, but 6 is. So I have 1, 2, 3, and 6, which means I have 4. Oh, 4 out of 6. I'm going to add these together, and then I'm going to subtract what they have in common if they have anything in common. They have the probability of what the outcomes they have in common. So they have 2 in common, and they have 6 in common, which means I'm going to subtract 2 out of 6, 2 options out of 6. And then that's going to give me 5 out of 6. Sorry. Yes. And that's 83.3%. And then for C, I have the probability of a prime number. So prime numbers are... What? Wait, I'm so confused. What did you wrong? Oh, never mind, I did that right. Okay, probability of a prime number is, the options for prime is 1, no, not 1, sorry, 1 is not a prime number. 2, 3, and 5, and then that is 3 out of 6. And then the probability of even, my options for even are, I already didn't need to write even, are 2, 4, and 6. So that's 3 out of 6. And I want to add these together because I didn't see the word or. And then I'm going to subtract the probability of getting, I have 2 in common, and I have, that's it. So just the probability of getting 2, which is 1 out of 6. And I'm going to subtract that, and then I'll get 5 out of 6, which will give me, again, 83.3%. All right, for number 5, you roll a die and flip a coin. These are 2 independent events, and I want to know what's the probability of both of these things happening at the same time, of the things given to me for A through D. So for A, I have the probability of prime. So the options for prime are not 1, 2, 3, and 5. And then the probability of getting heads, which is, so it's just 1/2. I have 1/2 times, this is 3 out of 6. I'm going to multiply these together. I see the word and. I want them to both be happening at the same time. So that's multiplication. And then I'm going to get, this is 3 over 12, which when I divide that in my calculator, I'm going to get 25%. So A is 25%. For B, I have the probability of even, which is 1/2, and the probability, oh my gosh, what am I saying? Oh wait, that's right. 2, 4, and 6 are my options, so that's 3 out of 6, which I'm just going to simplify to be 1/2. And then the probability of getting tails is also 1/2. I'm going to multiply those together, and that's going to give me, again, same thing, 25%. That's 1/4 or 25%. For C, I have the probability of a divisor of 8. So my divisors of 8 are 1, 2, and 4, which is 3 out of 6. Or again, I can just write that as 1/2. And then the probability of getting heads is also 1/2. So I'm going to multiply these two together. And again, I'm going to see that's 1/4, which is 25%. And then for the last one, I have the probability of getting a factor of 12. That is, the options are 1, 2, 3, 4, and 6. So that's 5/6. And then the probability of getting tails is 1/2. So I'm going to multiply these two things together. I'm going to get 5 over 12, which gives me about 41.7%. Ah, 41.7%. Then for 6, I have how many ways can 6 teachers line up to hand out awards for the seniors at BHS? I have, this is I see the word line up, or I see the words line up, which tells me this is a permutation. Order matters here. So I know order matters, and I know I'm going to use a permutation to find the number of ways. I want n. I know n is how many I have to choose from. Well, I have 6 teachers to choose from, so 6. And then r is how many spots to fill. Well, I want to line up all 6 of those teachers. So 6 people in that line, 6 spots to fill. And so r is 6 as well, which means I'm going to be doing 6p6. And I want you to actually do the work for this using the formula. The formula is n factorial over n minus r factorial. So in this case, it's going to be 6 factorial over 6 minus 6 factorial, which is 6 factorial over 0 factorial. I know 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, and 0 factorial is 1. When I do this in my calculator, I'm going to get 720 ways. For 7, the DMV is making summer license plates. They will have 3 letters followed by 3 digits. So that's a total of 6 spaces, 6 categories I'm looking at, or characters I'm looking at. So I'm going to make 6 spaces for each, and I'm going to find the options for each character, and then I'm going to multiply that all together to find for the entire license plate. How many ways. So, first restriction that I have that I'm focusing in on is that it needs to end. It needs to end with an even number. We're only counting 2. We're not counting 0 as an even number, so we're just doing 2, 4, 6, and 8. And so there are 4 options for the last digit. Sorry, these are going to be, these are going to be digits, the last 3, and the first 3 are going to be letters. So for that last digit, it's 4 options. Then another restriction I have is that it must start with an S. So it has to start with an S. It has to be S, so there's 1 option for the first character. Then I have the other characters I'm going to look at. I'm going to look at the letters first. So, and I need to keep in mind that no repetition is allowed. So after I pick 1 letter for the first character, I know that there's only 25 left for the second, and 24 left for the third after I pick the first 2. For the digits, I know I've already picked 1 for the last, so I'm going to have, there's a total of 26 letters, and a total of 10 digits to choose from, or 10 digits as options. So I'll have 9 digits left for that first digit, or the 4th character in the license plate, and 8 left for the 5th character in that license plate. These are my options for each character. I'm going to multiply all of these together to find the total if I combine all of them. And that's going to give me 1 times 25 times 24 times 9 times 8 times 4, which gives me 216,000 license plates. All right. For 8, your friends are putting together a committee to plan the school prom. There are 20 boys and 15 girls in your group. I want to know how many ways can you form a planning committee with 5 boys and 5 girls. There are 2 separate categories here. First things first, I need to decide, I know this is a permutation or combination question because it's asking me how many ways, and it's giving me some information it's not telling me, I need to calculate how many ways. And it tells me that because I see the word committee, that's another word for group, or that word means group, so I know that order is not important. Order doesn't matter, which means this is a combination. So I'm going to use a combination to find the total ways. There are 2 categories here. So I have boys and I have girls. I'm going to look at those two things separately because they're separate categories. So I have 20 boys to choose from, and I want to choose 5. So what I want is to find the ways to choose 5 boys out of 20 boys. And that's one category. Then I'm looking at this other category, which is girls. And there's 15 girls total to choose from, and I want to choose 5 of them. So I want to know the ways to choose 5 girls out of, I have 15 girls that I started with, or I was given. So for this committee, I want to know the total ways for me to get those 5 boys and 5 girls together. So I want a total of 10 people. In order to find these 2 separate things together, collectively, just like if I was looking for outfits, if I had 2 shirts and 5 pants to choose from, I know I would be multiplying those options for each together. Well, there's this many options for choosing the boys, this many options for choosing the girls. I want to know the options for choosing the 10 people. So I'm multiplying those 2 things together. And to rewrite this, what I have here is I have 20, choose 5 for the boys, and 15 choose 5 for the girls. I could use my calculator for this. You use your calculator, that PRB button. You look for NCR, and that's what you're going to use. For 20C5, if I put that in my calculator. So I put the 20 first, then I click the PRB button, and then I go down to NCR, then I put the R in, which is 5, and I'm going to get 15,504, and then for 15 choose 5, I'm gonna get 3,003. If I multiply these 2 things together, I'm going to get, for the committees, I have 46,558,512 committees possible. That's a lot. All right, for 9, there are 5 dimes, 3 nickels, and 2 quarters in a piggy bank. I want to suppose 3 coins are removed. So I'm taking 3 coins out of the, is it a bag? No, out of the piggy bank. I want to know what's the probability of selecting a dime, then a nickel, and then a quarter. So first I want to know with replacement. I want to know the probability of getting a dime, a nickel, and then a quarter. So I'm going to do the probability of a dime to start. And sorry, this is with replacement, which means after I take the first coin out, I'm going to put it back. The independent things that I have here, the independent events that I have here are the first pick, the second pick, and the third pick. And I want to know the probability of, on the first pick, getting a dime, on the second pick, getting a getting a nickel, and on the third pick, getting a quarter. Okay, the probability of getting a dime is, I'm looking at how many total do I have? Well, I have 5 plus 3 plus 2, which is 10. So 10 total coins in the bag. And then for a dime, I have 5 of those out of 10 are dimes. And then for nickel, I know 3 out of 10 of them are, and since this is with replacement, I'm going to take that dime out and I'm going to put it back into the bag. So there are still 10 coins in that bag, and 3 of them are nickels. After I put that coin back in the bag, there are still 10 coins in the bag, and 2 of them are quarters. I want all of these things to be happening at the same time. If I want them to happen at the same time, if I see the word and, which I do here, I know that I'm going to multiply these things together, and this is going to give me 30 over, oh, what am I doing? 30. Oh yeah, 30 over 1,000. So 30 over 1,000, which is 3%. Without replacement, I want to do, I still have the independent events that I have are the first pick, the second pick, and the third pick. On the first pick, I want the probability of getting a dime. On the second pick, I want the probability of getting a nickel. And the third pick, I want the probability of getting a quarter. The probability of it getting a dime on the first pick is the same as it was for with replacement. It's my first pick. Nothing's been taken out of the bag yet, so it's 5 out of 10. After I choose that dime and I take that out, there are only 9 coins left in the bag. And if I took a dime out, there are still 3 nickels left. For the third pick, I know there are only 8 coins left in the bag because 2 have already been taken out. And I'm not replacing them. So without replacement. So I have 8 coins left and 2 of them are quarters. I'm going to multiply these together because I want them to be happening at the same time. The probability of them happening at the same time, and that's 30 over 10 times 9 times 8. Oops. Which is 720. 30 divided by 720 is about 40. Wait, did I mess this up? Not 40. It's about 4.2%. All right, and then the next page I have for number 10, from a standard deck of 52 cards, 3 cards is, okay, this is wrong. Cross that out. That is not right. 1 card is selected. I don't like how messy that is, so I'm going to do that again. Cross this out. Only 1 card is selected. Otherwise, this question doesn't make sense. So from a standard deck of 52 cards, only 1 card is selected. I'm going to know what's the probability of a face card or a heart. So I'm going to find the probability of a face card, and the probability of a face card is going to be, there are 12 face cards in a deck out of 52. Then I want to know what's the probability of getting a heart. And the probability of getting a heart, well, there's 13 hearts out of 52 in the deck. I want one or the other happening from that 1 card selected. So I'm going to add these together. And then I'm going to take away anything that they have in common. Hearts and face cards only have 3 in common. The Jack, Queen, and King of Hearts. So those are 3 cards in common. So I'm going to subtract the probability of getting the Jack, Queen, or King of Hearts. That's 3 cards in the deck out of 52. I'm subtracting that. So I'm going to get, when I do that, 22 cards, 22 out of 52 is my probability. If I divide, I'm going to get 42.3% about. For B, I want a 9 or a black card. So the probability of getting a 9 is, there are 4 9s in the deck out of 52. Then the probability of getting a black card, so probability of a black card is, there are 26 black cards out of 52 in the deck. I'm going to add these 2 together, and I'm going to subtract anything that they have in common. So there are 2 black 9s in the deck, so there are 2 9s, 2 9s that are black. And one of them is, so I'm going to subtract the probability of getting the 9 spades, or the 9 of clubs. And there are 2 of those cards, so the 9 of spades and the 9 of clubs, so that's 2 out of 52. That's the probability of getting those. I'm going to subtract that, and then I'll end up with 28 over 52, and if I divide that, it is about 53.8%. Oops. It won't let me write the other part of the percent. there's another little, that's not a percent sign. It won't let me. Okay. For 11, I want to find each of the following. So I want to be able to recognize that A is a combination. This is a combination, which means I'm using the formula n factorial over n minus r factorial times r factorial. So I'll be doing 5 factorial all over 5 minus 2 factorial. Sorry, I'm going to read this smaller. So 5 factorial all over 5 minus 2 factorial, which is 3 factorial, times r factorial, which is 2 factorial. And I'm going to rewrite the number in the top in terms of the biggest factorial in the bottom. So I'm going to write 5 times 4, that's the next consecutive whole number less than 5, times 3, and I'm going to stop there. I'm going to write factorial because I know I have a 3 factorial in the bottom that I can cancel out. Since I know I'm going to be canceling out the 3 factorial, I'm going to rewrite the 2 factorial as what it actually is. It's 2 times 1. I'm going to cross out the 3 factorial in the top and the bottom. I'll have 20 in the top divided by 2 in the bottom. The answer to that is 10 for A. For B, I have 3 factorial times 2 factorial. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. I'm going to multiply these together. And it's going to give me 6 times 2, which is 12. For C, I have 0 factorial. You just need to know that that's equal to 1. For D, I have 8 factorial over 5 factorial. So I'm going to rewrite the bigger one in terms of the smaller one. So I'm going to rewrite 8 factorials as 8 times 7 times 6 times 5. I'm going to stop and just write 5 factorial. I know I have 5 factorial on the bottom. I can cancel out those 5 factorials, and I'm left with 8 times 7 times 6, which is 336. For E, I'm doing 4p2. So n is 4, and r is 2. And then I'm going to plug those into my formula for p, which is n factorial over n minus r factorial. So I'm going to have 4 factorial all over 4 minus 2 factorial. I didn't write that good. 4 minus 2 factorial, which gives me 4 factorial over 2 factorial, which is 4 times 3 times 2 factorial over 2 factorial. I'm going to cancel out the 2 factorials, and I'm left with just 12. And then for F, I have 6 C3. I know my N is 6. My R is 3. Whoops. My R is 3. I'm plugging those into the formula that I wrote over here by 11. It's n factorial over n minus r factorial times r factorial. So I'm going to have 6 factorial all over 6 minus 3, which is 3 factorial, times 3 factorial. I'm going to rewrite the top. 6 times 5 times 4 times 3. I'm going to stop at 3 factorial. I know I can cancel that out with one of the ones that I have in the bottom. I'm going to rewrite the other 3 factorial as 3 times 2 times 1. I don't have to really write the 1. I'm going to cross out the 3 factorials I have in the top and the bottom. I'm left with 6 times 5 times 4 in the numerator, which is 120, all over 6 in the denominator, and that gives me 20. For 12, I have a committee of 4 is to be selected from a group of 9 women and 7 men. So I have 9 women and 7 men. And I want to know what's the probability that 2 men and 2 women are selected. So as soon as I see men and women, I know that I'm doing 2 separate categories. This question is not asking me in how many ways can I choose this committee. It's asking me what is the probability. If I see probability for these problems, this is obviously a combination problem because I have the word committee, which means group, and order doesn't matter. I know I'm doing the favorable outcomes. So the favorable outcomes over the total outcomes. Favorable is going to be the specific. Actually, I should do this in a different color. Let me do this in a different color. So I have favorable Actually, sorry, I want to use purple to represent it because red and blue make purple. So favorable in the top and total in the bottom. Favorable is going to be the specific. So I'm looking at the specifics. I'm focusing in on the men and the women. And then the total is going to be the general. So for the specific, I need to look at the men and women separately. So I'm looking at the women first. I wrote this backwards. So I have to actually pick different colors for this. So there are actually 2 women. Doesn't matter because it's the same amount. But okay, I'm looking at the women first. I have 9 women to choose. So I want the possible ways to choose 2 women out of 9. So that's the first thing I want. The second thing I want is ways to choose 2 men out of 7. And then the last thing that I want, and that's what I want, those are my favorable things. I'm going to multiply them together to get the group of both of them together. So the 4, so the 2 women and 2 men together in the committee. And then the total on the bottom is going to be the ways to choose 4 people. I want to choose 4 people. Now I'm talking about the general, the people out of, I have, how many did I start with? 9 plus 7, 16 people I started with. Okay, so what I did here is in the top, I talked about the specific. I took each category at a time and then I combined them with multiplication. In the bottom, I talked about the general. So instead of defining them as women and men, I defined them as people. I didn't care if it was if it was men or women. And then from there, I could rewrite this as 9 choose 2 times 7 choose 2 all over 16 choose 4. And I know that these 2 numbers, the ends in the top, need to equal the end in the bottom. So 9 plus 7 should be equal to 16, which it is. And then I also know that the R's in the top need to equal the R in the bottom. So 2 plus 2 gives me 4. And then from there, I know I'm doing 9C2 in my calculator, 7C2 in my calculator, and 16C4 in my calculator. And I'm going to calculate what those things are. So in my calculator, 9C2 gives me 36. 7C2 gives me 30. Nope, what the heck am I saying? 21. And then 16 choose 4 gives me 1,820. I'm going to multiply and divide, and I'm going to get 41.5%, about. For the next one, I have a bag contains 8 real diamonds and 7 fake diamonds. I want to know if 8 diamonds are picked from the bag at random, what's the probability that exactly 4 of them are real? So again, I have 2 different categories here, real and fake. Just like in the last one, I had men and women. I have to look at these 2 separately. So I have 8 real diamonds and 7 fake diamonds to start. I want to know if 8 diamonds are picked from the bag at random, so that's the total. So 8 diamonds total. I want to know what's the probability that 4 of them are real, which means then 4 of them, exactly 4 are real, so 4 are fake then, if I'm choosing 8 total. I have all the information that I need now. I'm doing favorable, so favorable over total. To start, I'm focusing in on the specifics. So I have 8 real diamonds to choose from, and I want to choose 4. And then for the fake, I have 7 to choose from, and I want to choose 4. I want the combination of both of these things at the same time, so I'm multiplying them together to find the total ways of choosing those 4 and 4. And then in the bottom, I'm talking about the diamonds regardless of if they're fake or not. So I want to choose out of, I had 8 plus 7, so 15 total. 8 plus 7, 15 total. I'm choosing 8. 8 diamonds are picked. And then I'm going to do this. This is 8 C4, 7 C4, and 15 C8 in my calculator. And when I do that, I'm going to get 70 times 35 all over 6,435, which is 38.1%. For 14, this is not the question I want to do. The question is n minus 2 over 1 is equal to 2 times n over 2. This is a combination problem, so I have to convert these things into... I have to convert these into combination, or I need to use the combination formulas for this. The combination formula for this. And the combination formula is n factorial all over n minus r factorial times r factorial. So the first thing I'm going to do is I'm going to rewrite the left here. So I'm going to look at these combinations and I'm going to convert them. I'm going to plug in those n's and those r's into the formula. So for what I highlighted in red, if I rewrite that, or what I want to talk about with that, I'm going to erase what I have up here so I have enough space to do this. What I want to rewrite with that is I want to say n is equal to n minus 2. And I want to say r is equal to 1. And this is what I'm going to be plugging into my formula. So for the left-hand side, I know that I'm going to have n minus 2 factorial all over, and I'm going to have n minus 2 minus, I have r is 1 factorial times r factorial, which is just 1 factorial. I don't need to write 1 factorial. I know it's just 1. So I'm just going to not write that. That's equal to, on the other side, I have 2 times, and then the blue, if I rewrite that blue, I know n is equal to n. So I'm just going to replace everywhere in my formula that I see an n, I'm going to replace it with n, or leave it as n. And then r is equal to 2. And everywhere I see an r, I'm going to replace it with 2. So I'm going to have n factorial in the numerator all over, I'm going to have n minus 2 factorial times r factorial, which is 2 factorial. And this is it rewritten. I'm going to focus in on the left, and then I'm going to focus in on the right, and I'm going to bring them back together and solve. So I want to solve for n. That's the point of this. Okay, so on the left, I'm starting with, I have n minus 2 factorial in the top, all over, if I rewrite the bottom, that's n minus 2 minus 1, which is n minus 3 factorial. For this, I'm going to rewrite the bigger one in terms of the smaller one. The bigger one is n minus 2, because if I subtract 2 from n, it's going to be a bigger number than if I subtract 3 from it. So I'm starting with n minus 2, and then the next consecutive whole number down from that, one less than that, is going to be n minus 2 minus 1, and that's going to be n minus 3. I've reached what number I have in the bottom, so I can stop there, write the factorial sign, and I'm going to now cancel out the n minus 3 factorial in the top and the bottom, and I know that the left is just equal to n minus 3. So that's the left. Then I want to talk about the right part of this. So this part of the equation, and that gives me 2 times. In the numerator, I have n factorial. In the bottom, sorry, I'm going to actually rewrite. I'm going to rewrite the bigger factorial, that's n, in terms of the smaller factorial, which is n minus 2. So I'm going to rewrite n factorial as n times the next consecutive whole number down from that is subtract 1 from that, so n minus 1. Then the next consecutive whole number down is n minus 2. I'm going to end there because that's what I have in the denominator. So I have n minus 2 factorial in the denominator times 2 factorial, which is this 2 times 1. I'm going to cancel out the n minus 2 in the top and the bottom. And I'm going to be left with 2. Well, and now I can also cancel out the 2. So this is going to be 2. And this is 2. So I'm left with just n times n minus 1, which is n times n. N times negative 1 is n squared minus n. So this is what I have on the right-hand side. I'll have n minus 3, that's the left, is equal to n squared, n squared minus n on the right. And then this is a quadratic equation. I want to get everything to one side. This is positive on the quadratic, the n to the second power has a positive coefficient, so I want to get these to the other side. So I'm going to subtract n, add 3, and this is going to be 0 is equal to n squared minus 2n plus 3. And I'm going to try to... Wait, what? This is n minus 2. I'm so sorry. This should be n minus 2. N minus 2. So, starting from here, I should have n minus 2. So I'll be subtracting n and adding 2. And that's going to give me 0 is equal to n squared minus 2n plus 2. If I try to factor that, I'm not going to be able to. I'm going to check my quadratic, because this looks to me like, just looking at it, it looks like it's going to not be a real number. So I'm going to test if it's a real number or not by doing b squared minus 4ac. So actually, I should do this. I'm going to do b squared minus 4ac and see if that's going to be a real number or not. And it's negative 2 squared minus 4 times 1 times 2, which gives me 4 minus 8, which is negative 4. The square root of that, that's not a real number, so we did all of that for no solution. The answer is no solution. Because n is going to be how many to choose from, and it doesn't make sense for that to be an imaginary number. All right, I'm going to erase all of this so we have space for the next problem. Okay, so 15, 16, 17, 18, and 19, I want to know if it's a permutation or combination, and then I'm going to solve. So in how many ways can you arrange 5 letters 2 at a time? This, because I see the word arrange, order is important, order matters, so this is a permutation. And I know that I'm doing, my n is 5, because that's how many I have to choose from, and I'm choosing 2, so r is 2, so I'm going to do 5 p2, which is going to be 5 factorial over 5 minus 2 factorial, which is 3 factorial. That's going to be 5 times 4 times 3 factorial, cancels out the 3 factorial on the top and the bottom, and I'm left with 20. For 16, I know how many I want to know how many committees. Committees, order is important. Not important, I'm sorry. So order doesn't matter. Doesn't matter. So this is a combination. I know that I'm choosing n is how many I have to choose from, which is 16. I'm choosing how many for the committee? 3. There's 3 spots to fill. So I'm doing 16, choose 3. So that's going to be 16 factorial all over 16 minus 3, which is 13 factorial times 3 factorial. So that's 16 times 15 times 14 times 13 factorial, all over 13 factorial times 3 factorial. I'm going to cancel out the 13. I'm going to cancel out the 13 factorial on the top and the bottom. And I'm going to do this in my calculator. And when I do that, I'm going to end up with, this is 3,360 divided by 6, which is 560 committees. So 560 committees, this was 20 ways up here. For 17, I have how many bunches of 5 flowers can be made from 10 flowers. Bunches is another word for group. Order doesn't matter. So this is a combination. I know I have 10 flowers to choose from and 5 flowers I want in the bunch. So 5 spots to fill. So it's 10C5, which is going to be 10 factorial all over 10 minus 5 factorial, which is 5 factorial, times 5 factorial. So that's 10 times 9 times 8 times 7 times 6 times 5 factorial. I'm going to rewrite the one at the top in terms of the biggest factorial on the bottom. Then for the other 5 factorial, I'm going to actually write it out. It's 5 times 4 times 3 times 2 times 1. I don't really need to write the 1. I'm going to cancel out the 5 factorial in the top and the bottom. And I'm going to do this math in my calculator. And I'm going to get 30,240 divided by 120. And that's going to be equal to 252 bunches. For 18, in how many ways can 8 students be seated in 8 chairs? I have be seated tells me that order is important. So this is a permutation because order matters. I have 8 students to choose from and 8 chairs to fill. So that's 8p8, which is going to be 8 factorial all over 8 minus 8 factorial, which is just 0 factorial. 0 factorial is 1. So this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times, I don't need to write the 1, but I'm gonna. And then that gives me 40,320 ways. And then for 19, I want to know how many teams of 8 players can be formed from 15 players. This is teams. That's another word for group. So order is not important. This is a combination. I'm choosing from 15. I'm choosing 8. So there's 15 to choose from, 8 spots to fill. And this is going to be 15 factorial all over 15 minus 8, which is 7 factorial times 8 factorial. That's 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 factorial. I'm going to stop there. I have 7 times 6 times 5 times 4 times 3 times 2 times 1 times 8 factorial. And 8 factorials cancel out in the top and the bottom. You can check your answer by doing this in your calculator. And with the putting in 15, then C, then 8. But your answer should be, you have this in the top, and then in the bottom, 5,040, and you get 6,435 teams.